Alright guys, we look at today's lesson, we're looking at surface water. So yesterday we talked about water cycle, and we also talked a lot about where water was, how much water is really out there, how much water is really not out there. And so one thing we talked about is that water is pretty much everywhere. It's in the sky, it's on the surface, and it's under the ground. So we're going to be looking at over the next few days here, just kind of looking at it from all those different directions. We're going to be looking at it today and tomorrow from the surface water perspective. And then, in fact, then Thursday and Friday, we're looking at stream development, how streams act, how they behave, the common characteristics of all streams. And then starting on Monday, we'll start talking about groundwater and how that leads into caves. We will be doing some exploration activities, some of them labs, some of them not really too much of a lab. But those are some of the things we're going to be doing through this unit. So this is actually kind of a long unit. I'm looking at maybe having a test next Friday, maybe, but possibly even the week after next is where we'll have our next test. So this can, we're going to kind of drag this unit out a little bit, get you guys used to where our water comes from. So that's kind of the whole point of where we're going. So one of the things I want to start off here when we think about water is the very first question. What is the major force behind the movement of water? What makes water move? Very simple question. Why does it go downhill? Why can't it go uphill? Gravity. The number one driving force behind all the movement of water is gravity. And Brandon, as you said earlier, water hits the ground, where does it run? Downhill. Okay? That's what we call runoff. Anytime you watch water moving down the slope, you got runoff. I remember one time, I'm not sure why I wrote that up there. So runoff is basically the downhill movement of water. Share a little story with you guys here. A good story that kind of goes along, fits into the file of things you know but didn't think about until it was too late. Things you realize if you were to take just 30 seconds to think about it, you would have realized this is a bad idea. So I'm in Boy Scouts and we're at a weekend camp out, and we had this huge campsite. My friend and I were deciding where to put up our tent for the night, and we found this perfect spot. Perfect spot. It really was a beautiful spot. What we didn't think about was the fact that it's actually sitting right at the base of a hill. And we knew it was going to rain. It just seemed like the perfect spot to be. So we woke up the next morning, and the way that the tent was situated, we were still somewhat on a downward slope. So my friend is literally floating in the water that had collected inside the tent. So my bag was a little damp. His was completely soaked, and it took him and 4 other adults just to get it out of the tent. So this is the whole concept of runoff, and what it really means to have all that water draining down the side of the hill, collecting inside your tent. So that's just some of the things,
So your tent was storage.
A little miniature reservoir. So when we think about runoff, we ask, okay, where does all that water go? Well, some of it collects in the tent, depending on whether or not you're staying there. How many guys have basements that flood? Okay, that's the same concept. All that water's got to go somewhere, so it runs downhill. Most of your basement floods because of groundwater, so we'll talk about that next week. But basically, it floods because all that water hits that basement wall, and it has nowhere to go but to seep through the wall of your basement up through the floors. So that's kind of the concept there. But all this water basically runs downhill, and it goes into a lot of different places. Brandon?
Remember last summer when the heavy rains started coming? My dad's basement flooded. He had to get a sump pump that wasn't even in the basement. So when we got it out, there was just cracks in the ground. And I would stand on one of the blocks. You could just see water coming in.
That's kind of cool, actually.
I thought that was
So we think about where the water goes. Basically, most of it, as you can see here, goes into your lakes and rivers, oceans. That's where most all that water drainage goes into. So we look at our region. Where does all of our surface water eventually end up? Nope. Which lake? Great Lakes. There we go. So when we think about our major drainage basin, ours basically all drains into the Great Lakes, which then eventually drain into what? The oceans. It actually goes out through the St. Lawrence Seaway.
But it's not going. So you're saying like the Great Lakes are upward, so going down.
Yeah, the oceans are bottom. You can't get any lower than the ocean. So everything, truly, like the little saying out of Finding Nemo, all the drains lead to the ocean. And then whatever it does, at some point the water from our area will eventually make it into the ocean. And it does that, like I say, if you look at our region, our rivers drain north to the Great Lakes, either to Lake Erie or to Lake Michigan. Those are your two options. If you go a little bit farther south of us, towards Indy, most of their rivers start draining to the south to get to the Ohio River, which then drains into the Mississippi River, which then drains into the Gulf of Mexico, which is basically the Atlantic Ocean. Okay? So really all of our water does make its way through the ocean at some point in time. So that's kind of where all this water is going. Well, one of the things that's kind of important is that with runoff, we actually have a really bad issue with runoff. Has anybody ever seen water cut through cement?
Yep.
Okay? You get that nice little fine water jet, and it can literally slice right through rock. And that's the concept of water. You get water moving fast enough and it has enough power to erode and literally slice through solid rock. That's what we call erosion, right? How many of you guys have ever been driving down the road, you look at a bank, a ditch, and you see these little grooves that have been cut into the ditch? You guys seen them before? That's from the water moving across that flatland and then going down the hill. When water starts moving downhill, it's literally like having a handsaw and you're slicing down through the ground. And that's what erosion is. So one of the things we look at, and we, for whatever reason, think erosion is this horrible thing. You know, wasn't for that, we wouldn't have the world as it is, but it's okay. So when we look at building housing communities, we replace, and we literally, if you think about it, you take farmland that is able to soak up a whole bunch of water, and we replace it with homes and roads. What's the problem? Why is the water now when it hits that?
Well, now it's underneath whatever we built there, the water that's underneath it built up.
Oh no, the problem is it can't even get underneath it. So you start putting cement down, the water hits the cement and just runs off. Okay, so you take this really great land that is able to soak up the water, and we've now created a lot more runoff. So a lot of times what we ask ourselves as builders is what can we do to reduce the amount of runoff? So there's several factors that affect the rate of runoff. One of the first ones is vegetation. Think about a barren land with a lot of water. Is there anything to hold that soil together? So what happens as soon as the water hits it? Just carries the dirt away. So vegetation actually does several things. This is my really crude attempt at playing Plinko. Okay. Think about vegetation. It does a lot of things. One, the roots hold the soil together. Prevents the soil from being eroded away at the root level. But one of the other things it does, and this is one of those big truths I want you guys to make sure you know out of this whole unit, is that the faster water's moving, the more it can carry. Make sure you guys understand that connection. The faster water is moving, the more it can carry. Which means the more that it can dissolve, the more that it can erode. So if you slow down the water, you can lower the effect of erosion.
So is that like what they talk about the rocks and the something that gets so smooth? So is it the slower the water flows, the more jagged the rocks are?
Exactly. So when we think about that, what we need to think about then is, as we're building stuff, is how can we slow down that water? Put stuff in front of it. Okay? So you can imagine this as being a forest of trees going down a hill, and in comes my water. Now, if I just let this thing drop, it drops fairly fast, right? So think about that with water. It's just literally going to go right down the hill. But by having a little bit of vegetation, whether it's brush, bushes, trees, even flowers, what happens is the water hits that, and what does it have to do? It has to go around it. So it takes a much longer time for it to actually reach the bottom. So you actually are slowing down that water, and by slowing it down, you can actually increase your infiltration rates, which decreases your runoff, which therefore decreases your erosion. Okay, so vegetation is one of those most important pieces to preventing erosion. The next one is the rate at which it's raining, or snowing, or melting. Again, kind of common sense to think about this one. If it's just a small little mist, you're going to get a lot of runoff. But if it's a downpour, you're going to get a lot of runoff. So again, yeah, you would think, okay, that's so common sense, but you know, like, you just don't think of listing that as one of the reasons or effects of runoff, but it really is the rate at which we're having precipitation.